Philips MicroDose Mammography is a full-field digital mammography system. It uses a cutting-edge and unique direct digital photon counting technology. Photon counting detector technology has been a paradigm shift in mammography, allowing for high dose efficiency, enabling low radiation dose levels without compromising image quality. In this presentation, we will explain how this is possible. MicroDose is a multi-slit scanning mammography system, and the assembly consists of the X-ray tube, the pre-collimator, the post-collimator, and the photon counting detector. During the examination, the breast is first compressed and then scanned by the small detector and collimators to acquire the image. During the scan, the radiation exposure is adjusted automatically, thanks to the smart automatic exposure control, depending on the density of the breast. The result? Unnecessary radiation is avoided. A common measure of the imaging system performance is the System Detective Quantum Efficiency, DQE, also called dose efficiency, and it includes scattered radiation rejection, detector performance, and energy weighting. We will now show how the MicroDose mammography system achieves high dose efficiency. With a standard detector, when X-rays pass through the breast, there will always be scattered radiation. Scattered radiation reduces the contrast and increases the noise, which must be compensated for by increasing the radiation dose to the patient. We will now look at how using two separate collimators almost entirely removes scattered radiation. The pre-collimator in the MicroDose mammography system removes photons that are not initially directed toward the detector from the beam. These photons are useless and would otherwise only contribute to the patient's radiation dose. The post-collimator absorbs those photons that are scattered in the breast and not directed toward the detector. Using two collimators, Philips MicroDose mammography eliminates 97% of the scattered radiation without using a grid, enabling low dose without compromising image quality. Another factor contributing to MicroDose's high system DQE is the performance of the photon counting detector. The system has a multi-slit geometry, and the detector consists of several detector lines that are scanned over the breast. Each line creates a redundant image, meaning interpolation is never necessary. The result? No information loss due to dead pixels. Furthermore, the detector lines are made of crystalline silicone, which has excellent electronic properties and very good energy resolution. Each detector element is very small, achieving 50-micron image resolution. By placing the strip detectors in edge-on geometry to the X-ray beam, a sufficient absorption length is created, resulting in high detection efficiency. Each detector line is made up of a number of channels that each contribute to individual pixels in the final image. You now see an enlargement of one channel. An electrical field is applied across the detector. X-ray photons are absorbed in the detector. On each entry, the X-ray photons induce electrical pulses that are counted as digital output. Because the Philips MicroDose photon counting detector is fast enough to be ready when the next photon arrives, there are no ghost images that can interfere with image interpretation or slow down your workflow. In other words, every photon counts. The pulses are easily detected, since the pulse height is much higher than the electronic noise in the detector. Thus, the detector counts the number of peak pulses and nothing else. With no conversion steps from X-ray photons to a digital signal, as in a traditional detector, the detector noise can be removed almost entirely. The MicroDose photon counting detector is also sensitive to the energy of the X-ray photons. Low-energy photons that have passed through the breast contain more image contrast information than high-energy photons. Standard detectors assign a higher weight to the high-energy photons, wasting information, while the MicroDose photon counting detector is able to weigh low and high-energy photons equally, therefore improving dose efficiency by 10%. We have now explained how Philips MicroDose mammography eliminates 97% of scattered radiation, provides high X-ray photon absorption, fast direct digital photon counting, absence of electronic noise, improved energy weighting, 100% pixel warranty, and no ghost images. Furthermore, Philips MicroDose mammography has one of the market's smallest pixel sizes, enabling visualization of fine structures in the breast. This means high dose efficiency, allowing for low radiation dose without compromising image quality.